We are talking about exponential growth and exponential decay functions, and we want to find an account balance using compound interest. So compound interest is when the interest is compounded n times per year. The amount A in an account after t years is given by the formula below. A equals P times the quantity 1 plus R divided by N, all raised to the N times T power, where P is the principal or the starting amount, and R is the annual interest rate expressed as a decimal. So we have all of our variables here. And we can go through and we can use this example 8 down here at the bottom. You deposit $2,000 in an account that pays 4% annual interest. Find the balance after 3 years if the interest is compounded. And then there's 5 different options here. First one is daily. So there's a number of things in the equation that we have to come up with. We got to know P, we got to know R, we got to know N, and we have to know T. So things that aren't going to change in this case, the number of years is always going to be 3 years. So 3 years is never going to change because that was designated up here. So for each one of the scenarios, 3 is always going to be our T value. The number of times per year it's compounded, that is going to change based on the directions. 4% is the annual interest. So 4%, but we have to write that as a decimal. So as a decimal, we want to use the 0.04. Keep that as a percentage. And the principal is the amount that we start with. So this is going to be $2,000. So those are what we know. And the only thing that's going to change is the number of times compounded per year. And that's going to change the amount that we earn. So daily, in that case, we're talking about daily. That's what we're talking about. N is 365. So when we plug that into the equation, that's the formula that we want to use. So we're trying to calculate A, or the amount that we have. The principal that we have is 2,000. And that is going to be multiplied by 1 plus the percentage as a decimal, so 0.04, divided by N, which is 365, and that is raised to the N, which is 365, times T, which is 3 power. So we can plug those into our calculator, and for this example, we get A is equal to 2,254.98. And so that is our example for daily. Weekly, how does that change? In that case, everything stays the same, except for N is going to get changed to 52 times because there are 52 weeks in 1 year. So everything else is going to stay the same. A is equal to 2,000 times 1 plus 0.04 divided by, and then times 3. And the only thing that's changing now is we are dividing by 52, and 52 goes into those 2 places. Everything else is the same. The principal is still 2,000. We still have the 1 there because we're increasing our money, so we want to be above 100%. The 0.04, that's the percent or the rate as a decimal, and t is 3, that's still the number of years. And so when we use our calculator and we calculate that out, we get $2,254.89. So everything's the same. We lost a little bit of money compared to daily because it's compounded more often. So the more often your money's compounded, the more money that you can earn. We have a couple more examples to look at. We have monthly. So in the case of monthly, we know that n is 12. And quarterly, in that case, we know that n is 4. So we can substitute that in for our equation, and everything is going to be the same except for the n value is going to change. So a is equal to 2,000 times 1 plus 0.04 . So everything stays the same. And the only thing that changes is n changes. So we're dividing by 12, and the 12 goes in the exponent. And when we get done there, we see that a is equal to $2,254.54. So again, everything's the same except for our cents. We're earning a little less. And then the last one, we actually have 2 more. N is equal to 4. So 2,000 times 1 plus 0.04 divided by 4 times 4, or raised to the 4th power times 3. And when we plug that one in to our calculator, we find out that we get 2,253.65. So now we're even almost $1 less than we were here at 12 times a year compounded. And then let's take a look at E. In E, in this case, we're changing 2 variables. Compounded quarterly. So quarterly means that n is equal to 4. And if we have that percentage there, that means that the R value is going to be 0.0425. So we can calculate A is equal to the principal, which is 2,000 times 1 plus, then we can put our percentage up there as a decimal, and our compound rate, and we're still doing it for 3 years. It is compounded 4 times a year, so that goes in those 2 spots, and then our percentage goes 0.0425. And when we calculate that out, we get the amount we're left with at the end is $2,270.44. So we can see that we make quite a bit more money in 3 years, almost $17 more with the higher percentage rate.